Okay, let's have a look here at this question. A is the set of points representing modulus of z equals 5, and B is the set of points representing z plus z conjugate equals 8. Plot A and B on an Argand diagram. Interesting. And determine the point of intersection. That's an interesting one now. So let's see now. Maybe 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. That's a little too close together. We'll make that 10. 5, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then that's 10i, 5i, 6, 7, 8, 9, 1, 2, 3, 4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first one, A is where the modulus is 5. So that's just a circle around there. That's set A. A little bit harder now is set B. So set B, am I recording? Yeah. Set B is where z plus its conjugate is 8. So like for example, it couldn't be something like 3 plus 4i plus 3 minus 4i, because that only adds up to 6. So you can see that the real part would have to be 4 plus, and it actually doesn't really matter what happens with the imaginary part, because the conjugated means they cancel. So as long as the real part is 4, then I guess that does the job. So it's just going to be the vertical line at 4. That's all. Yeah, that's it. So that's B at 4. And then we want the intersection points. So that's here. Well, actually, I can see what that is, because if that's 4, and then that's 5, I think you can see what's happening here. That's going to be a 3. And then likewise here. It's a 3, 4, 5 triangle. So you can see that Z1 will be 4 plus 3i, and Z2 will be 4 minus 3i. And that nicely takes care of the first question. The second question now. Okay. We want to write this in polar form. So root 3 plus I over root 3 minus I times root 3 plus I over root 3 plus I. That will equal, in the denominator, 3 plus 1. And on the top, it would be 3 plus 2 root 3i plus I squared. So that would equal 2 plus 2 root 3i over 4, which is a half plus a half root 3i. The OR is the modulus of that, which would be a quarter plus 3/4 Yeah, so that's 1 then. And then this is in the first quadrant. So you have tan theta is this over this. The halves cancel. So you'll just have shift tan inverse root 3. So pi over 3. So the answer is just going to be cos pi over 3 plus I sine pi over 3. Let me just get my calculator here, the other one. Okay, where is it now? Where is it? Here we go. Let's double check this answer. Okay. Yeah. And then cos pi over 3. Yeah, it's all looking okay. Now, we want to find the least positive value of n such that Zn is a real number. So Zn would be cos n pi over 3 from De Morgan's theorem plus I sine n pi over 3 equal only a real part. So that means then that the n pi over 3 has to be an angle where sine of it is 0. Well, and I assume we can't use 0 for n, because that'd be too trivial. Has to be positive. Yeah, so the next time sine is 0 is at pi. So then that would mean n would have to be 3, looks like. So I think that's the least value, huh? Okay. Lastly, indicate clearly on the Argand diagram the following. X squared plus y squared equals 4. Okay, let w equal 2z squared, w equals u plus... verify that. Okay, that's another tricky one. So I'm not going to go to the same trouble I did last time of marking everything in nice and neat. Well, maybe I will a little bit. So x squared plus y squared equals 4. Very similar. It's just where... It's just a circle again at 4. Oops. Minus 4. And then minus 4i. That's k. Indicate clearly on the Argand diagram in the z plane the set k of z defined by... Yeah. Okay, now w equals 2z squared, and w is complex number as well. We can find x and y in terms and verify that the image k is that. Okay, so let's see. W equals 2z squared, which equals 2 x plus I y squared, which equals 2x squared plus 4 xyi plus 2y squared I squared, which equals 2x squared minus 2y squared plus 4xyi. So therefore, u will equal 2x squared minus 2y squared, and v will equal 4xy. express x and y in terms of u and v. It's the other way around then. And verify that the image of k in the w plane is the circle. Okay, gonna need to make a bit more space. Right. So I don't think this is necessarily the best way to do it. Okay. If you square all the points and double it, we should get a circle of radius 8. I wonder how difficult it would be to rewrite this. Let's find out. X is v over 4y. So then that means 2x squared, which is 2v squared, over 16y squared minus 2y squared equals u. That doesn't seem right. Hang on, do you know what? Give me a minute to think about this before I jump into it, because this is quite different to what we usually see. Okay, so it just occurred to me that probably the easiest way to show that this is the image of this is just to show that this can be simplified back to this using the rule I just have here. So u squared plus v squared equals 64. So that means 2x squared minus 2y squared squared plus v squared equals 64. Let's see what happens. 4x 4 minus 2, 4, 8 x squared y squared plus 4y4 plus 16x squared y squared equals 64. So we can divide by 4. x4 minus 2 x squared y squared plus y4 plus 4x squared y squared equals 64. 16. Actually, this is looking good, because then what I can do next is x4 plus 2x squared y squared plus y4 equals 4 squared, and that's x squared plus y squared squared equals 4 squared, which means x squared plus y squared has to equal 4. So I've verified that. That's good. The last thing to do, which I think is kind of tricky, is to express x and y in terms of u and v. And perhaps it would be best to rearrange this. So rather than try to solve this particular pair of equations, which kind of looks a bit not too appealing, It might be worth trying to take it from a different angle. I could say z is root w over 2. Could see what happens. Now, just in case that doesn't work, I'm going to leave those two equations at the bottom. Worst case scenario, I'm going to have to solve those two equations for x and y. Okay, so we have z equals w over 2 square root. No, oh dear, I don't think this is going to work. U plus IV power half. I'd have to change them into polar form and go backwards. Oh, okay. It's looking like I have to solve these pair of equations and then I'm finished this question. Is there any sneaky thing I could do here? Oh man, I'm gonna have to think about this before I jump in. Right, so what I've done, I've actually wanted to check what the answer is. So I went into a website here and checked the answer, and it's really a monster of a result. Really monstrous of a result. This is what I'm trying to get to, if you want x and y in terms of u and v. I'm starting to wonder now if that's a typo in the question, if it meant to say express u and v in terms of x and y. Because those were the equations I needed to show that this equation simplifies to that. Really just has me wondering if this is the wrong way around. If it says express u and v in terms of x and y, I'd have those two equations, which I substituted into this to show that it simplifies back down in the original Argand diagram as the circle. Unless I'm missing something. But I did check it here, and that's what x and y would be in terms of u and v. And w is the u and v, and the x and y is in the z. Z is x plus iy. So it has the squares in it. So yeah, unless it's a typo, it's gonna be one heck of an equation. Okay, here we go. I don't know if this is going to work. All right. Let's solve for... Let's eliminate x out first. So, yeah, we have x equals v over 4y. Sub that in. So I get u equals 2x squared minus 2y squared multiplied by y squared. So that's uy squared equals, that's v squared over 8 minus 2y4 multiplied by 8. 8uy squared equals v squared minus 16y4. So we have 16y4 plus 8uy squared minus v squared equals 0. So we have y squared equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Can take out a 16 and that would be a 4, so I can divide by 4, so that's minus 2u plus or minus root u squared minus 4v squared over 8. Is that what it is here? Oh, they simplified a bit more, huh? Could be the same. I don't know. I don't know. They simplified more. I'm not going to go any further than this. Root plus or minus, I guess, 2u plus or minus root u squared minus 4v squared over 8. And then that would mean x equals v over 4y. So that'd be v over 4 plus or minus, and then root 8 over minus 2u plus or minus root u squared minus 4v squared. Let's do a quick check of all this algebra. Okay, so x is v over 4y, yep, and then that got subbed in there. So that's 2v squared over 16y squared minus 2y squared. What did I do next? That's multiplied by y squared, so that's uy squared. That leaves with v squared 2 over 16, which is 1 over 8, minus 2y4, multiplied by 8, so there's an 8 there, no 8 there, and a 16 there. Take that to the left, that's a 16, the 8 still there, and minus v squared, and it's a quadratic in y squared, so that's minus b plus or minus the square root of, b squared. 8 squared is not 16, it is 64. So that means there's a 4 there, which I can take out again. That's good. Okay, good thing I checked. So now we're okay up to here. So 64 comes out as an 8, dividing by 8, so that's gone. That's gone. And then instead of 32, it's 4, isn't it? So, yeah, actually that's a little bit nicer. So that means plus or minus the root of that. So that would mean x would equal v over 4, 1 over y, plus or minus the root of the reciprocal, 4 over u squared plus or minus root u squared minus v squared. Okay. And that's x and y in terms of u and v. 64 is 8, 8, 8. Yeah, that leaves a 4. Oh, actually, yeah, I could simplify it even more because the square root of 4 is 2. So, I can actually just put that over 2 and have y equals plus or minus and the root's just on the top. And then here, the root of 4 is 2, and the 2 will cancel the 4 here to make a 2. So it's just a 1 there, and the root's there. Okay. So it was v over 4, but now it's v over 2 because the 2 there cancels, and it's just that. And actually you could simplify that if you wanted to rationalize the, well, I guess, yeah, I could maybe simplify it, but let's not. I think this question has gone on long enough. Wow, 25 minutes.